Alright, so a little quick rundown of my testing apparatus that I've been using for a while. So this down in the middle is the big old breadboard I assembled that I've been testing out stuff on. If you could focus, that'd be nice. But that is, well, the PCB on the right there, you see. That's mostly organizational. There's a couple passives there and diode and a resistor on there, a flyback diode because inductive load, resistor because a pull-up resistor, and there's one of those pairs per each of the FETs, and all those wires are just taking the gate and taking the different taps, like like taking a little center tap for the actual line too, and then just bringing them over to these little headers over here. So you can't really see it, but underneath the breadboard, you can see it. You can kind of see it. But there's just a row of pins, and that, because, you know, breadboard, just makes it so it's easy to plug in, disconnect, and yada, yada, yada. So on the left over here, we just have the little teensy 3.1, and that's what I've been using to do all of the control, all of the, anything I want to control, really. Currently, it's hooked up. I was in the middle of still debugging the half-bridge driver over here. You can see it soldered onto a row of 8 pins. But yeah, still can't figure out what's wrong with that. I think I might have just might have static ESD'd it, or something bad. But anyways, moving back over to this side, we have just a whole bunch of little bits. Ignore the resistor sticking up. That's just kind of temporary storage area for components. But on the left, you have a couple switches and a little trim pot. My hands are huge. And that's just so I can kind of adjust the throttle and adjust a couple little things while I'm testing and tinkering out stuff. Just hooked up to a couple digital, well, a couple analog, one analog and 2 digital pins on the teensy. Nothing crazy going on that side. And you can see, jumping back to this board, you can see these middle thingies, these wires, just go to a little bundle of alligator leads, so I can fairly easily hook this up to just about whatever I want. Which means I can hook that up to this thing, and this is just a kind of simulated brushless motor, like a WYE configuration brushless motor. Fancy word for it's a whole bunch of resistors, and they're all soldered together at the back. I stuck some. You can kind of see it down there, but I stuck some thermal paste on there because these are 10-watt resistors, and they will hopefully, when I'm testing it and actually being able to run all of them, they will be dissipating a hefty amount of power. So I have them all like strapped down to this giant aluminum heat sink with a PCB. I'm using more structurally than anything else right now. But yeah, and that's just because I wanted this exists because I wanted a resistive load to test on before I went to the whole brushless with coils and everything, because the coils can because it's an inductive load, you get voltage spikes, and that can make life difficult. But yeah, it's effectively the same thing to the motor. To the motor speed controller, not the same resistance, so it's not going to be dissipating the same power as the motor can, but still it'll be able to make sure that when I have this like turning on and off, that it's actually turning on and off, and like can push a lot of current without killing itself. So yeah, you can see the brushless motor. You have just 3 leads coming out of here. You got 3 leads coming out of there. Got 3 leads coming out of here, so everything works nicely. For powering this board, The power is the actual like motor power rails are separate from like the rest of the breadboard. I believe these two lines, it's these two lines. These two lines are power taps, so these go to the actual high and low rails on these half bridges. But that's the only point on this breadboard where any high current and high voltage is going to be going through. All the rest of it's going to be logic signals and such. These two alligator clips right here, these two, you can't maybe see it. There's copper bars sticking up out of the PCB, and that's what you clip onto. Negative on the left, positive on the right. These are kind of not hooked up right now because they are kind of not hooked up right now. I mentioned my power supply died, so that's bad. So that's about all. Not a whole lot else. The oscilloscope's here for debug.